Hey Ryan.
What's up?
Hey, how are you today? How was the Memorial weekend?
Memorial weekend? We had a little barbecue.
Oh, that's good.
Yeah. And I finished like organizing my room and like now like 2 days yesterday and today
Hmm.
there's like there's always like a volleyball meet like outside my like park, so it's like I just go there to exercise.
Oh, what do you do? Like calisthenics or like pull-ups, push-ups,
Oh, at
lifting
my park,
weights?
it's really hard to find a calisthenics bar, so I just built like a concoction of like metal. Like I disassembled a chair. I disassembled a chair and then I just recreated it so I can like have like a bar. I don't know. It's
Oh,
like the thing where you do L sits from. So
mm, L sits. Yeah, yeah, nice. Can you do a handstand or like a yeah, cartwheel or backflip or anything?
oh yeah, while you were away, I
Hmm.
took my basically we got like 4 years ago a random package was shipped to us
Uh-huh.
and it was like an inflatable mattress.
Oh, it's a mattress?
Yeah.
Yeah.
It's like we it was because like it wasn't supposed to belong to us. It was supposed to go to someone else, but we got it instead. We just had it for 4 years, and like a couple of days ago, I opened the box and then I just set it up myself. So now I have an inflatable mattress in my room along with another mattress, and like everything's like I have a small room, but I made the most of it.
I see. Yeah, dang. That's good. Like you have like two mattresses then, huh?
Yeah.
Yeah.
So I use one to like practice handstands where I just kick up and then I my feet hit the mattress instead of the wall.
That's so comfy.
You know.
Dang. Yeah, yeah, yeah. Last Thursday, I had to like cancel the office hours because my parents came over, and at Davis, and then I had to like go eat out dinner with them.
Okay.
Yeah, yeah.
What'd you do Friday, Saturday, and Sunday?
Friday, let's see. Let me check my calendar really quick. Let's see. Yeah, let me sign in for this one. 15474. Okay, come on. Okay, so on Friday, I basically stayed home, rested, tutored some like private tutees, and then on Saturday I went to San Francisco, went to Japantown, Chinatown, uh, the whole day basically, and then yesterday Sunday I just rested, I tutored, and then today I tutored like almost all day today.
Oh,
Yeah. So the I went to SF like basically over the weekend to go a lot of places.
that's F. I feel like I know that place.
Yeah. San Francisco.
Oh,
Hmm.
hmm. That sounds like fun.
Yeah. It was a good break, like good getaway from school. Because I only have like 2 more weeks left, including this week and then finals week. So basically 3 weeks left, and then I'm on like summer vacation.
I see. Wait, summer
Hmm.
vacation when?
After I graduate, June 15th. So June 15th is the day I walk, like the stage, and then after that, like I'm in summer vacation.
Oh,
Mhm.
so did you finish your finals already?
No, 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 no. Finals is my last final ends in June 12th.
June 12th.
June 12th. Yeah.
In what subject?
Organic chemistry.
Should be
Yeah.
easy for you since you tutor it.
Yeah, 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 yeah. It's open note too, so like I could just go back to my notes,
What the
stuff like that. Yeah, no.
They just want you to pass at that point.
Yeah. It's not a regular like undergraduate level class like a college level one, but it's a graduate level class, a graduate level OChem class. So it's a higher level than like the regular college one.
Hmm.
Yeah. Because I already passed that one. Like that's the class I tutored. I just wanted to take the higher level one just so I could like learn more and know more about it. So I could like tutor it better, like have a better understanding on it.
Mm.
Hmm. Yeah. Have you been resting so far, like over the thing, or have you started on the grind, like the AP
I
Chem
started on
everything?
the grind
Oh,
today.
dang.
I'm like doing my like I have summer homework like
Uh-huh.
for AP Ling.
Oh, AP Lake homework? Oh my God.
Yeah,
Oh, here's Joseph. He joined. Hey, Joseph.
he joined.
Hello, how's it going?
Yeah, it's going well. It's going well.
Did you go to San Francisco with Joseph or?
No, 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 no. He didn't go. He was at a grad party for a friend.
Mm. So basically, right now I'm like trying to do all this like I'm trying to like have like a school format where I like study like from well tomorrow I'm gonna be going to the pool so I
Mm-hmm.
can like exercise or like swim like 10 you're at 10 a.m.
Mm-hmm.
But basically right now I've been looking at a bunch of resources for like at College Board, Khan Academy, and then like Note KNOWT
Right. That website that you showed me.
You
AP
should look
Chem.
at Professor Dave as well.
What?
Professor Dave.
YouTuber, Professor Dave, the guy with the long beard, long
Uh-huh.
hair, I mean, and then with the beard as well. Yeah, he's a good YouTuber for the house.
Oh, I'm looking him up. Let's see.
And for AP Chem, I also recommend Tyler DeWitt. Let me type that in the chat. Tyler DeWitt. And of course the organic chemistry tutor, like the guy that
Yeah.
teaches everything.
Wait, does the organic chemistry teacher teach more than organic chemistry or what?
Yeah, yeah. He teaches physics, algebra, AP Chem, calculus,
He's
like a
goaded.
whole lot of subjects. Yeah.
Hmm. Yeah, I'm just subscribing to all of them. Let's see, organic chemistry center. Any more resources? Because I'm just gonna keep like studying like the whole day. Yeah.
I saw
Because
this
like I
website on
Mhm.
Reddit where this website here basically condenses and organizes the subjects into like the correct order. And then that should be helpful.
Mhm.
Muhammad. Oh, hey, Muhammad.
Hello?
Hello.
Hello, hello. Is this your
Hello.
first one here, first session here? First session?
Yeah.
Yeah, nice, nice. What time is it there for you? 5 a.m.? 5 something a.m.?
Yeah, it's 5 a.m. I
Oh my
almost
God.
overslept, but I came in through clutch.
Oh my God. That's good. What time did you
Yeah.
wake up?
I woke up like 10 minutes ago.
Oh, 10 minutes ago. I see.
Like I put an
Dang.
alarm to like join you guys. So
Uh-huh. Are you like in bed right now, or are you out of bed?
now I'm actually in bed.
Oh, okay. That's interesting. Nice. So
Yeah.
Ryan is here, like the guy that you commented on my videos, like the
Bruh,
yeah.
Ooh, wow, okay.
nice to meet you.
Yeah.
To meet you, man.
Yeah. What in the UK, like how is it structured? Like is it like ninth grade, 10th grade, 11th grade, 12th grade? Is it high school, or is it like
Oh.
grade 1, grade 2?
So like it's actually kind of complicated. So um before no, when you finish school, you get like a certificate which say like it's called the GCSEs, which
Hmm.
literally stand for General Certificate of Secondary Education.
Right, I
And
heard of
then
that test
once you get
before.
that,
I heard of that before.
Mhm.
oh okay, that's good. So then once you get that, you then choose which pathway you wanna go to. So like if you wanna because most universities accept A levels, so that's what I did because I wanna
Mhm.
go to medicine.
Medical
So I
school,
did
right?
A levels.
Mm-hmm.
Pardon?
Wait, for medical school, medicine, yeah. Do you have to take the MCAT as well at the UK, or like how do you apply to
Yeah,
medical
we
school?
have something like that. It's called the UCAT.
Oh, the UCAT, the UCAT.
Yeah, but the difference is that once you finish your A levels, you go to medicine straight away. You don't do like an undergraduate and then you do medicine.
I see. Dang,
Yeah,
it's interesting. Oh my God. And
and the A levels are only 2 years. So
only 3 years,
Wait,
right?
MCAT is like American or like US. What is the one for the UK?
UCAT.
UCAT?
UCAT, yeah.
Yeah.
MCAT stands for Medical College Admissions Test. What does UCAT stand for?
It stands for it stands for like it's a I forgot. Let me search it up. I actually
Uh-huh.
forgot. I don't know how I
Yeah,
forgot
yeah,
it.
yeah. That's okay. Like, oh, well, what year are
Yeah.
you on the A levels? Like the first year, out of the
Uh,
2 year?
the first year, yeah.
Oh,
I'm on the
okay,
first
okay.
year.
Yeah. Dang.
It stands for the University Clinical Amplitude Test.
Oh,
Yeah.
amplitude.
So it's an amplitude test though.
Nice. How long is it? How long is the test? Like for the MCAT, it's like 7.5 hours. Like once you get there, you get out like 7.5 hour
Seven and a half
shift. Yeah, yeah. But that's including the lunch break and the small breaks as well. Like you get lunch break.
lunch break for an,
Yeah,
oh my
yeah,
god.
yeah.
For
And
the UCAT isn't even that long. It's like maybe 2 hours max.
oh yeah, no break at all. Like straight through.
Yeah. Yeah.
Just like a final. Yeah.
Hmm.
Oh my God.
But
Mm.
how does it work in like America? Like
Mm.
I don't
So
get the APs and stuff. I don't understand them.
yeah.
I mean, I'm glad I dropped 5 APs.
Are
Right.
they like
So
hard?
they are like college level classes that you could take during high school, and if you pass them, which there are standardized tests every year, you get to skip like that college class. It depends though. Like sometimes like the college allows you to skip it, sometimes they don't. Depends on your major and the college you go to. But it prepares you like well for those college classes as well.
AP
Oh,
stands
I
for
see.
advanced placement.
Advanced placement classes. Yeah.
Ooh, I see.
But honestly, just take dual enrollment if you can, unless you're. I mean, I'm not sure how it is. Like community college in the UK is like so.
Yeah. Are there community college there or like local colleges?
Um, uh, I'm not. Nah, I don't think so.
I
Most of them
see.
are just like governmental colleges.
I
I see.
see. What's the difference between college and the uni there at the UK?
Oh, so yeah, so so in the UK, we don't actually refer to universities as like colleges, because
Uh-huh.
like once you finish school, if you want if you want to as like I said, you go to like different pathways, and you
Mm.
also choose if you want to go to a college or a sixth form. So like sixth form is basically just like school, just 2 more years of school. But if
Uh-huh.
you want to do if you go to a college, it's like uh it's just like a center where you go, because they treat you like adults. Because there are actual adults that are studying over there as well in colleges, but in sixth forms it's just school.
Mm. It's cool. I
Yeah,
see, I see. That's interesting. Oh my
yeah, it's really
God.
interesting.
Which part of the UK are you from? Like, which city?
I wasn't born here. I came here though.
Oh, you came there. I see, I see.
Yeah, I came in from the Emirates.
I see.
Yeah.
Oh. Hey, Justin.
Oh, hey Brian.
Hey, how are you?
Good. I wasn't sure if you had office hours today or not.
Yeah, yeah, yeah. I have office hours Monday to Thursday. Sometimes like when I don't, like I will remove it on the calendar on the school.
Okay.
Like last Thursday I didn't because I had to like eat out with my family. So that's why I canceled the last Thursday.
Okay.
Yeah, yeah, yeah. Oh, is your exam tomorrow or on Wednesday?
Actually, it's tomorrow.
Oh, it's tomorrow. I see, I see.
Yep.
Yeah, so Justin here, he goes to my school right now, UC Davis, and then they are taking organic chemistry right now, and they have the exam like tomorrow.
Uh,
Yeah, yeah,
so we all
like
have it tomorrow.
yeah. Oh, these people here, they're not from UC Davis.
Oh,
Ryan is a 16-year-old high school from Sheldon High School.
Starting junior year next fall.
Oh, junior year. Yeah, he just finished high school. He just finished his sophomore year. Um, Muhammad is a 16-year-old from the UK. Um,
Wait, what
I-
grade is he?
yeah, what grade are you,
I'm
Muhammad?
in
Or is it
what you guys
year?
call grade 11.
Grade
Yeah.
11 year. Yeah,
Yeah.
I see.
okay.
How many grades are there at the UK? Like 12? 12 grades?
There's yeah, there's 12.
I see, I see. Yeah, yeah. So similar to here. And Joseph, he already graduated college. From SJSU, San Jose.
Oh.
Yeah. Let me get my iPad really quick, connect it, and then I could answer your questions, Justin. Be right back.
Alright, thanks.
Yeah.
So everyone here is like from the US, except for Mohammed.
Yeah, so where exactly from the US are we? I'm from California, so
California too.
California.
Yep.
NorCal or SoCal?
Me probably more North Cal.
Are you from the Bay?
No, not really. I'm from like a small town or small city, Roseville.
What's the closest big city?
Sacramento would be it.
Oh, okay, so you're pretty
You live
close
close.
to Davis.
Yeah. Actually, I'm
Yeah, all Sacramento,
going to
like,
Davis.
yeah.
Oh shoot, I was muted. Oh, wait, what's your plan after graduation, Justin? Like, are you pre-health, pre-med, pre-dental, pre-vet, PPA,
Probably pre-med
pre-med? Yeah,
or
yeah, yeah. There's a lot of pre-meds.
if med school would accept me.
Are you?
Wait, Brian too.
Shut up. Are you taking the MCAT soon, or like when are you registered for the MCAT?
I mean, technically, once I finish organic chemistry, I can take the MCAT, but to actually apply for med school, I need a bachelor's degree, so that's gonna be a while.
I
So
see. I
technically, I
see.
could take the MCAT, but I mean, there's also like a limit to like as
How
soon
much you
as you
could take?
take it. Yeah.
Yeah, lifetime is 7.
Yep.
Oh, really?
Yeah.
I need to take my DAT dental admissions test again. It's gonna be my 3rd time.
And he didn't study for the second time. Like he registered for it again, and then like he just like crammed it into the last week, and then he was I don't know what he did.
Right.
Mhm.
Yeah.
Dude, I would take it, fail it, and then just have that thing in the back of my mind haunting me and just study like a madman after that.
Yeah.
So the first time I took it, I only studied for like I think 3 weeks, and then the second time was a week and a half. So now
He
I
got the same
actually need to
score, same
study.
average score.
All right. Does anyone
Yeah.
have any questions for Brian right now? Or is there if I go?
Yeah. I think you could go. Like they're not taking OChem now.
Okay. Let me share my screen so you can kind of see the
Mm.
questions.
Wait,
So,
let me make you co-host really quick. And I can annotate on the Zoom as well. Let me stop
okay.
sharing on this one. There you go.
All right. Let me see if we can share it just so you can kind of see the exact questions I have. So this is on the practice midterm,
Right.
and specifically on question 3 here. And let me
Which of
see
the
if there's
following molecules would produce carbon dioxide among other things when treated with HiO4? Okay.
yeah.
So when you see HiO4, right? Wait, I'm trying to find an annotation tool on my
Yeah,
iPad.
because this one I believe it's what is it? Oxidative cleavage.
Oxidative cleavage, that's right.
Yeah. So I'm
Um,
just wondering how do we know how it cleaves looking at this? Because typically I think the example Helix gave us was oxidative cleavage within Fisher projections. So
mhm.
kind of like C,
Right. So
and
the
that's
thing to know
now.
about this reaction is that if you do this reaction with an aldose, you only get 2 types of products. It could be a formic acid, like the carboxylic acid with the hydrogen attached to it, or formaldehyde, that aldehyde with the hydrogen attached to it. Those are the 2 different things that you could get from an aldose from this reaction.
Okay.
I would write it down, but I don't know where the annotation tool is. I don't know why it's not working, like annotating tool. So I'm just gonna explain it verbally, and then if it doesn't make
Sure.
sense,
Let me
just
try
let me know.
this. Does it work now?
Oh, there you go, there you go. It works now. Yeah.
Yeah, I
There
was
you go.
pausing to share.
I see. Okay. Right. So in aldose reacting with HiO4, you're gonna get a formic acid and formaldehyde like this, right? Where both of those are single carbon units. Like there's only 1 carbon in those molecules there.
mhm.
If you have a ketose and you react that with HiO4, then you're gonna get the same single carbon units plus carbon dioxide, CO2 gas, right? So in this case, they're asking for which one of these molecules would produce CO2, which
Mhm.
in this case, they're basically asking which one of these came from a ketose. Right?
Okay.
In the cyclic version, the ketose anomeric carbon includes an alcohol and a CH2OH. So
Right.
we know that the rightmost carbons here are the anomeric carbons. Anomeric carbon, anomeric carbon, and this is the anomeric carbon there.
Mm-hmm.
For the open form, this C of the tro aldehyde is the anomeric carbon because the anomeric carbon is always the carbonyl carbon. Right?
Okay, wait, how are we able to identify the anomeric carbon? Like, how can we kind of say it was this here or this here? Like, how we know specifically on that side
Mm.
of
Right.
the oxygen?
The anomeric carbon is conventionally drawn at the rightmost side of the Haworth projection or the chair
Mm-hmm.
conformation. Right, because we also see that this oxygen here is the one attached to the anomeric carbon, right? Where that oxygen there is the nucleophile that attacked the carbonyl carbon. So it's
Okay.
always the rightmost carbon that's an anomeric carbon in these Haworth and chair conformations, right?
Okay.
In this case, we're gonna look for the one that has both an alcohol and a CH2OH. Which one would that be? Which molecule would that be?
So is it both? Okay, I guess it would be this one here, B,
Mhm.
which is the only one.
Right. Which that came from a ketose. Because when you look at the structure of a ketose, it looks something like this. At the very top carbon is a CH2OH, the bottom carbon is a CH2OH, and then the second carbon is a carbonyl, like that.
Mhm.
And then everything else in the middle doesn't matter. It could be like some random stuff. For
Okay.
an aldose, the very top carbon is a tro, and then the middle stuff is some random stuff, right? Where this tro here is representing this aldehyde there,
Mm-hmm.
right? A ketose, think of it as a ketone. An aldose, think of that as an aldehyde,
Mm-hmm.
right? Where the tro is that aldehyde carbon right there. The ketone is this carbonyl carbon right here, where there are two R groups in between that carbonyl, right?
Okay.
Like this is the carbon here attached to that carbonyl, and this is also a carbon there, which is a ketone.
Right. I think my biggest question is like, how does this cleave? Because typically to cleave it, I believe for oxidative cleavage,
Mhm.
you need like an OH group next to another OH group. Like for
Mhm.
example, do they have to be on the same side, or can we like cleave between
Yeah.
those two?
They don't have to be on the same side. You could cleave
Okay.
between these two as well. You could do that. They don't have to be on the
Okay.
same side, right? Nice.
Okay. I'm just assuming that water probably reacts with the CH2OH group to create an OH, is my guess. I'm just wondering how it cleaves
Mhm.
specifically this group here to form
Mhm.
the CO2 group. Because
Right.
my guess is going to it's going to cut specifically one carbon and probably produce CO2. Because yeah, when we cleave the OH groups, it leaves
Mhm.
an oxygen, I believe, if I
Right.
remember
So
correctly.
in this reaction here, this will happen in the open linear form. So
Mhm.
we have to open this up into the Fisher projection first. Are you familiar with opening up like Haworth projection to Fisher projection and vice versa? Like closing a Fisher projection to Haworth projection? Like going
Um,
in between those two projections?
I'm kind of loose on my foundation, but I have a general idea. I'm still trying to wrap all the
Uh-huh.
information down.
Right. So I'm just gonna draw out the open form of that
Mhm.
cyclic version and then let me know if this makes sense. Mhm. So this is the linear form of that Fisher projection B right there, where I'm gonna circle the anomeric carbon, that carbonyl carbon there, as a red dot. That red dot is this red dot right there,
Okay.
right? The mechanism for this right here, when the water reacts, it would react with this carbonyl carbon right there and make that carbonyl oxygen and OH. And then it does that whole mechanism that you see on the lecture slides, right? Because we could redraw this Fisher projection as this right here. Like let's say H, H, OH, and then you could say this is like OH, H, after we put water through it, right? And then this could be OH. Everything else stays the same. And then the bottom carbon, I'm gonna expand that CH2OH out into this format here, the CH2OH, where you notice how all of these like carbons here, like there's a alcohol nearby on each other like that.
Mhm.
That's how you do the mechanism there for this reaction once we expanded it to the open Fischer projection form. Right.
Okay.
Nice. And I highly doubt the mechanism for this reaction is going to be tested. The most likely thing that's going to be tested for this reaction is what kind of products are formed
Hmm.
from this reaction.
So just need to recognize an OH next to a CH2OH group, most
Mhm.
likely.
Yeah, for a ketose, that would form a carbon dioxide, right? Because that's this section here, the ketose is the only one that forms carbon dioxide. If you have an aldose, no carbon dioxide is formed.
Okay, got it.
Right, right.
Right,
And another
thanks.
important thing that you might need to know is that the formic acid will come from the carbonyl carbon, CHO, plus the number of secondary alcohol. And then the formaldehyde will come from the number of primary alcohol. For ketose, the formic acid will come from the number of secondary alcohol. Formaldehyde will come from the number of primary alcohol. And the CO2 will come from the carbonyl carbon.
Okay, thank you.
Yeah, no problem. Let me screenshot this and so I can save it to the notes. Okay, there we go. Okay. Clear. Oh, nice.
Wonder, does anyone else have any questions? Because I don't want to like hog, all of your time. I may have I have multiple questions on this practice exam, but I'm just asking if anyone else has questions for Brian.
No, go ahead.
Okay, thank you. I just don't want to be too selfish here.
No, it's
Because
okay. It's
I
okay.
heard we all have a midterm tomorrow, so
Midterm tomorrow, Wednesday. But that's like use Davis. But these people, they're not taking OChem like right now.
oh, okay.
Yeah.
All right, and then let me see if I can find my next question. It was so I'm just trying to check. I have like my paper notes in hand, and I'm trying to compare it with this. It was no. So yeah, it was on naming these sugar groups. So how do we tell? Because I've seen Helix give me an example of this in Fisher projection on how to
Yeah.
name like D and L groups or based on the position of the OH group. I'm wondering how would I read that for a group that's in, sorry, I don't remember the name of this type of
Howard's projection.
Howard's projection.
Right. So we would have to first open it up into the Fisher projection and then name it from there, from that Fisher projection. So
Okay.
the first step is to locate your anomeric carbon, which is this. This annotation tool is not working. Let's see. Wait, hold on. I think it's my pencil. All right. That carbon there. This carbon is the anomeric carbon, which we said is always the carbonyl carbon. We're gonna make a cut between that anomeric carbon and that oxygen right there.
And just to confirm, the anomeric carbon is always to the right, correct?
Yeah.
So does that mean that's always where we're going to cut for converting it to Fisher projection?
Yeah.
Okay.
That's right. That point there, from that rightmost carbon between the oxygen and that rightmost carbon there, that's where we cut to make it open. Right. And we said that was the carbonyl carbon. You notice how that dot carbon also has a hydrogen? That is going to come an aldehyde right there. Is this an aldose or a ketose?
It would be an aldose.
Right. And the O that cut right there becomes an OH because now the ring is open, right, into its linear form like that.
And just out of curiosity, can you maybe give an example of a ring that would result in a ketose?
Yeah, a ring that would result in the ketose would look something like this. Like, there we have that. This CH2OH, OH, H, and then let's say CH2OH. The same first step, we locate our anomeric carbon, which is this rightmost carbon here. Once we have done that, we make a cut between the oxygen and the anomeric carbon. When we do that, we know this anomeric carbon is a carbonyl, right? Where this oxygen is this oxygen of the carbonyl right there. But this is a CH2OH, so let's draw that CH2OH here. Now you can see that that came from a ketose because that's not an aldehyde, that's a ketone. Everything else stays the same. Wait, wait. A ketose would have an alcohol and a CH2OH at the anomeric carbon. An aldose will only have an alcohol and a hydrogen on the anomeric carbon, right? Because
Okay.
the anomeric carbon here, the hydrogen is that hydrogen of the aldehyde. If the anomeric carbon has a CH2OH, that's the R group of the ketone, ketose.
Okay, so the big determining factor is the CH2OH on the anomeric carbon.
Versus
Determines
the H.
ketose. Okay,
Ketose is CH2OH on the anomeric carbon. H on an aldose for on the anomeric carbon.
got it.
Right. So once we get to this open form here, let's redraw this into the Fisher projection where I'm going to represent that aldehyde as CHO. I'm going to go straight down and say that the alcohol is down there, that alcohol there. Let's number this A, B, C, D, E. Right? So it's going to be A, B, C, D, E. A is the carbonyl carbon, which is that C of the CHO. B, C, D, E. Does that make sense so far?
Yep.
Great. Now let's look at carbon B. If you see alcohol on the bottom side, that means that it came from the right side of the Fisher reaction, right?
Mhm.
If you see alcohol on the top side, then it will come from the left side. It will go to the left side. But since the alcohol on carbon C is going down, it's also going to be on the right side that I drew there, right? But on carbon D, you know how there's nothing there? Like there's just hydrogens, invisible hydrogens. We draw those invisible hydrogens out like that, right? Because carbon D, there are hydrogens here on that carbon, which are these hydrogens on carbon D right there.
Okay.
Right. And the reason why everything on the right side is down and everything on the left side is up is because imagine this vertical line here of the Fisher projection as my arm, my left arm.
Mm.
I'm going to topple it or rotate it 90 degrees to the right like that, right? Imagine this alcohol, if it's on the right side, is this pencil right here.
Mhm.
When that happens, and I topple it 90 degrees to the right, you're going to see that that alcohol is facing down, right? So that's why everything on the right side of the Fisher projection is down. Everything on the left side of the Fisher projection is up. Because let's say we look at the hydrogen perspective now, which is on the left side. If I rotate it 90 degrees clockwise, we will see that that hydrogen is going up.
Okay.
Right. So that's an important thing to know. Everything on the left side of the Fisher projection goes up. Everything on the right side of the Fisher projection goes down.
Got it.
We see this portion here of the Fisher projection. It could be CH2OH. Like we could redraw that Fisher projection and write it out as this CH2OH.
Mhm.
This is the C, and then it has two H's. That's the CH2 part, and the OH is the OH there. Okay, does this make sense so far? Like how I got to that purple Fisher projection?
Yeah.
Great. So now to name this, there are three components for the name. You first determine if it is a D or L sugar. The second step is you determine if this is an aldose or a ketose. And then the third one is look at the number of carbons. So first, is this a D sugar or an L sugar?
I'm just wondering, because to determine if it's D or A, when we compare the what's the anomer carbon to the other anomer carbon here, when we like look to compare if there's a CH2OH group versus an OH group,
Oh, right. I think you're thinking of
because I
the
think we
alpha or
could.
beta anomer. That's different than D or
Oh
L
wait.
sugar.
Oh, actually, yeah, you're right. That's alpha and beta anomer.
Yeah, alpha or beta anomer, right? To determine if it's a D or L sugar, you look at the last chiral center, which is
Mhm.
that last point right there. Do you remember if the alcohol has to be on the right side or left side to be considered a D sugar?
Then wouldn't it be D, I believe? Because don't
Mhm.
we rotate this one over, I think, when
Mm,
comparing, or am I wrong?
You're thinking of closing the ring, like when we want to rotate the groups.
Oh, okay.
Right. In this case, we're not closing the ring, we want to open it up. So we're not going to rotate any groups here. We're just gonna focus on this last chiral center that I started here. Do you see that point that I started right there?
Yep.
Right. You notice how the alcohol is on the right side?
Yeah.
If it's on the right side, it's a D sugar.
Okay.
Right. If it's on the left side, it's an L sugar. Right.
All right.
The rotating thing is only when you're closing the Fisher projection to Haworth, and the CH2OH thing with the OH thing, like alpha or beta to it, is like looking at that like anomer thing, which is different than D and L sugar. Right.
Okay.
So since we know this is a D sugar, that's the first part. Is this an aldose or a ketose?
Okay. So that would be yeah, aldose. Could an
Aldose.
aldehyde group.
Right, the CHO. You see the CHO, aldose.
Mhm.
Omit the SE of the name. So it's gonna be D, aldo. And then for the number of carbons, right? We're gonna count that from the very top carbon. 1, 2, 3, 4. 4 carbons long.
Okay.
So it's gonna be tetros. Tet showing the 4 carbons, and then os is showing that it is a sugar. The OSE showing that's a sugar. Right.
Right.
A common mistake that people do is that they put D, aldo, butose. But we don't do bute, we do tet. Like it's not like the other naming system, like butyl is 4. We do like tetra for
So
4.
does it count the number of carbons or does it count the number of, I guess, connections in the ring?
It counts the number of carbons in the whole Fisher projection, right? Not the number of connections, like in the middle carbon, it counts the whole carbon collection, like the top and bottom, including like that, those carbons as well.
Oh wait, it's tetras because we're including the carbon from the CH2OH group.
Yeah, and
Oh,
the
okay.
CHO as well.
Okay.
Wait, but since it's 4, don't put butose, put tetros for 4. Right. Another common mistake people make is that if it is a 3 carbon chain, right? People might say for this one D aldo propose. But that's not right. It's gonna be D aldo trios or trios. Right. So that's the most confusing part. If it's a 3 carbon sugar, tri or tri. If it's a 4 carbon sugar, tet. Right. It's not gonna be prop or bute. It's gonna be tri or tet. That's the common mistake that people make.
Okay. So is 3 and 4 the only, I guess, suffixes that we change? We change propose to trios and then tetros. Oh no, sorry. Yep, tetros for, I guess,
Bute.
propo for propane, I guess.
Oh, for butane.
Oh, bute. Okay.
Right. Everything else stays the same, like mono. Oh, actually, no. Everything changes actually because you know how with the propane and butyl, like that is going with the methane, ethane, propane,
Mm,
butane, pentane. That is going with the first and second one as well. Because if you only have 1 carbon, then it's not gonna be meth. It's gonna be mono. If you have 2, it's not gonna be eth. It's gonna be di. If you have 3,
okay.
it's not gonna be prop. It's gonna be tri. If you have 4, it's not gonna be but. It's gonna be tet.
Oh, the classic mono, di, tri, tetra, penta.
Yeah.
Oh, okay. They're
And then from penta and then hexa, that's like when it gets like the same.
okay.
Yeah. Mhm. Yeah. Yeah, so that's the answer for that. D-aldotetrose. First, open it up to the Fisher projection. Condense. You could condense it. It's optional. Condense the CH2OH down, and then
Mhm.
follow the 3 steps there.
Okay. And I think I have just one more
Mhm.
question on this one.
Yeah.
So it's very similar. The question's on B, which is converting to Fisher projections. I know we kind of went over it again. But again,
Oh,
it's
yeah.
always sorry, I keep forgetting the term of this, the anomeric carbon.
Anomeric carbon, right. Not aromatic, and anomeric.
Anomeric.
Yeah. Some people like mix it up. They say aromatic sometimes, but it's not aromatic. It's anomeric.
Got it.
Right.
So yeah, that's where we always cut, and then we
Mhm.
just rotate this a little bit, I believe, when we do the Fisher projection, right?
We kind of rotate it, but then that carbonyl carbon right there. What is it in the Fisher projection? Like what kind of carbon is it? Like what is the hybridization of the anomeric carbon?
I believe it's anomeric carbon, I guess sp2.
Yeah, sp2 for Fisher. Where the anomeric carbon is always the carbonyl carbon. Is this gonna be an aldose or a ketose based on what we see on the anomeric carbon right now?
Okay, so I believe it's going to be an aldose.
Aldose, right? Because we have an H, not a CH2OH.
Mhm.
And what does it mean to be an aldose? What kind of functional group do we have?
For an aldose, don't we have a CH2OH group at the anomeric carbon?
Oh, that's gonna be a ketose. Like
Oh,
ketose
sorry.
is when you have a CH2OH at the anomeric carbon.
Yeah, aldoses, we don't have
Uh-huh.
CH2OH at the anomeric carbon.
Right. And then an aldose, we know that we have an aldehyde, right? Not a ketone, an aldehyde for
Hmm.
aldose. So first, let's draw that aldehyde out like that.
Mhm.
Everything else will stay the same. And then the O right there becomes OH. And then CH2OH, I want to draw like that. OH. 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 Does that make sense so far? Like how I made that cut and then made that carbonyl carbon into an aldehyde, and then the O becomes OH?
Yeah, I believe we just pronated the oxygen there, we formed the OH, and then it pulls the electrons, and then we form the O double bond and depronate it.
Nice.
Okay.
So I'm gonna label those atoms A, B, C, D, E, F,
Mhm.
where I'm gonna label the aldehyde as CHO, like this, right? And I'm gonna go all the way down and make that last carbon OH. B, C, D, E, right? Where this is A, B, C, D, E, F. Does this make sense so far? Like how I got to this form?
Yep.
Great. So now let's look at B. If the OH is going up at carbon B, where would that be at the Fisher projection? Left or right?
Let's see if we went to B, that should be, I believe, left.
Right. Yeah, nice. Everything on the going up is on the left side. Everything going down is on the right side. That's an important thing to remember. Right, that's great. Left. How about for carbon C?
For carbon C, that should be right.
Nice. Carbon D?
Carbon D should be left.
Yep. E?
And E, I believe the OH group on the, I guess, methyl group should be left.
Yeah, it's not
I'm
an
not
alcohol,
sure.
it's a
Or CH2OH.
OH, right. So this is technically a Fisher projection, but not the conventional way. Because you know how in the conventional usual Fisher projection, we always have a CH2OH on the very bottom for sugars?
Mhm.
What we have to do at the very end is rotate these 3 groups in a way that would make the CH2OH go down. So we're going to rotate those 3 groups like that, in that direction.
Okay.
Right? When we do that, we're going to get the CH2OH at the bottom. And where would the OH be now?
Should be to the right.
Nice.
So we
And
always rotate the direction to favor the CH2OH group at the bottom. So we don't
yes.
always rotate it clockwise. It could be either direction
Right.
that we
It
need
could
to.
be
Okay.
counterclockwise or clockwise, whichever favors the CH2OH going down.
Okay.
Right. Only for ring opening. For ring closing, we want the OH at the very bottom if we're trying to close the ring. But this is ring opening, which is the opposite.
Okay.
So this is the final answer.
Okay. So why did we rotate it? The CH2OH group to the bottom again?
Yeah, these are basically the same thing, but we rotate it to make it at the bottom to get the regular conventional Fisher projection way, the regular representation way.
Okay, and we only do that for ring opening, correct?
Yes, only for ring opening. Right.
Okay, and I'm guessing for ring closing, we always have to have the OH at the bottom because
Mhm.
that becomes our, I guess, that O link in between.
Yeah, yeah. And then that's how we can determine where the CH2OH is going to go up or down. Because at this point right now, when we try to close the ring, we can't tell if the CH2OH is going to go up or down because it's not on the left or right side. But if we make the OH rotate downwards, the CH2OH, where would that go in this example here? Like if we rotate the OH and the CH2OH and H this way, where would the CH2OH go?
I guess it'll go always to the left.
Right, in this case, in this
So
example, for the D sugar.
yeah, so the
But
OH is at the bottom. Okay.
But if you have something like this though, where would you rotate? How would you rotate? What direction?
Counterclockwise
Right. And where would the CH2OH go at that point?
to the right.
Yeah. So does that mean is it gonna
Okay.
go up or down? The CH2OH?
It would go. Oh, that would go down, I guess, in
Yeah,
terms
it
of
will
the
go
ring structure.
down. Yeah. Yeah, that's the difference.
Okay.
Right. But this is the final answer that we're looking for.
Okay. Thank you.
Yeah, no problem. Just for extra practice, try naming that Fisher projection.
Which one?
The final answer one. This one here.
Okay.
Try naming this sugar.
Let me see here. So we have. Okay, so we have an aldose. 1, 2, 3, 4, 5, 6 carbons. Oh wait, and we rotate it always to the bottom so we can figure out if it's D or L. Is that why we do that rotation?
Yeah, that's part of the reason.
Okay. So it should be L 1, 2, 3, 4, 5, 6. So ethyl, propyl, butyl, pentyl, hexyl. So sorry, I'm gonna have to write it down. My memory is pretty bad.
No,
L
that's okay. Wait, so if alcohol at the last cross
X.
center is on the right side,
Mhm.
it's a D sugar. Like if the alcohol is on the right side, it's a D sugar. If it's on the left side, it's an L sugar.
Got it.
Right. So this is a D sugar here.
Oh, is it? Oh, right, because it's on the right.
On the right
So I
side.
keep. Oh yeah, so that should be D.
D.
So D aldo. That's 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5. Yeah, 6 carbons.
Mhm.
So D aldo hexatrose
Just
or
hexos. Hexos.
oh hexose.
That's nice. Hexos. Not hexotros, just hexos. Nice. Right. Because I think you thought of tros because of tetros, right?
Yeah,
Yeah. It's just for tetros that has a tros there. Like trios doesn't have a tros there. Pentos doesn't have a tros there. Hexos doesn't have a tros there. It's just tetros with the tros.
got it.
That's it. That's the name for that one.
All right, thank you.
No problem. I hope that helped.
Oh, it helped tremendously. I've been scratching my head for the past few hours trying to figure out naming because we went over this question. I've stopped sharing for now. No, but we went over this concept very briefly in lecture. I think there's only one slide for it.
Oh yeah.
And he just gave us like, here's an example of a name and didn't quite explain the details and
Yeah,
the
like
patterns and how, we identify which components we put to which part of the name for it.
right, like how to open it up, like how to tell which one's the anomeric carbon, what the anomeric carbon is. He just glossed over the example and like expected you to practice your own after that.
Actually, yeah, I think we only got one example for the mechanism for opening.
Yeah, that sucks because that's not the only example that you will see. Like there are other examples that are tricky and like more involved.
Yeah, and then I saw in the practice exam, like, whoa, okay,
Yeah.
better know that.
I know.
All right, thank you, Brian.
Yeah, no problem, Justin. Good luck tomorrow.
Thanks.
You got it. Okay. Nice.
Yo,
Yo,
you want to know what happened?
what happened?
I got rejected from my job.
Oh, the recreational center one?
Yeah.
Oh
The thing
no.
is, I'm kind of glad I got rejected because, like, I'm looking at the location. It's 52-minute biking.
Oh no, that's a sign. It's not a rejection, it's a redirection.
Yeah.
Yeah. Yeah, dang, that's good. Like if you were to get in, like you would have to bike like 52 minutes like every time to your shift.
There and then back.
Oh my God, that's 2 hour commute from
2
biking.
hours. No, thank you.
No, yeah, and the heat too.
Mm-mm.
Yeah. Muhammad, do you have a job? Are you working? Any, or just like, are you on summer vacation? Are you finished with school?
We're actually in like a vacation
Oh, you're on
right now,
vacation, summer
but
vacation.
not the summer holidays though. So
Oh,
yeah, I meant holiday. Sorry, not vacation. Like literally vacation.
uh-huh.
But
They don't call it summer
they call
school?
it just a midterm
Oh,
holidays,
Oh,
and it's
like
only 1 week.
only 1 week. I see. Dang,
Yeah.
I see. That's
But
interesting.
can I ask a question?
Yeah. Mhm.
So is an aldose just an aldehyde, but with like the actual group on the like and most carbon?
Right. An aldose is an aldehyde, functional group at the very top. A ketose is a
Mhm.
ketone at the top.
Yeah.
You know what an aldehyde and a ketone is? And you're
Yeah, of course.
wait, what the heck?
We get
Dang.
taught on that.
Oh.
I do chemistry. I do chemistry A level, so we get taught
Oh.
on organic.
Oh, that's impressive. Like,
well,
and not even
wow.
in, dang,
Oh, thank you.
dang.
Do you guys not get taught on that? On
Not
like APs and
for AP Chem and Gen Chem. I think I'm not sure. That was so long ago. Um, the functional group. Yeah. I'm not too sure. I forgot.
oh.
Yeah.
But obviously I'm in year 1, so it gets like we get into more detail in year 2.
Yeah. And then once you get to that more details, you can drop by here and ask questions, and I'll hopefully I can help
Oh,
you out.
okay. Thank you.
Yeah. Dang,
But that's
that's
interesting. So, but does an aldose have to be in like a sugar?
an aldose has to be sugar. Whenever you have an ose, like OSE at the end of the chain, it's always a sugar.
Oh
Right.
wow.
An aldehyde doesn't have to be sugar. An aldehyde could just be like from any functional group, any group,
Yeah.
any like chain. It could be a fat, it could be a lipid, anything.
Oh, that's so interesting.
That's more.
Because we get taught on like biological molecules in biology, but not in chemistry.
Yeah. This like stuff relates to biology. Like they're
Yeah,
connecting. Yeah.
that's so interesting.
Well, in my school, they only have like one class for biology. It's like freshman year, but I kind of forgot all that information. And then like, and then
Is that all like the DNA replication, transcription, translation, things for that bio freshman class?
yeah, this year I took like chemistry, but it was like regular introduction to chemistry. It's not like actual chemistry class.
Yeah. Like moles, molarity, balancing chemical equations,
It's a simple
basics,
part.
basics.
It's harder afterwards, so that's why I'm trying to like achieve, just
Mhm.
like study for everything, and then when I come back to school, I'll be prepared and actually have fun in my other classes.
Yeah. I see. That's crazy. Wait, so you have 2 years left of high school, right? And then Mohammed also has like 1 year after his year one A level.
Yeah,
Yeah.
I see. And then after that, it's the uni.
I have time, but like now I just like I quit I quit video games and I deleted all my socials, so I don't have to worry about the outside world right now.
That's how road, yeah. Focus on yourself right now and stuff like that.
Yeah.
Dang. Are you applying for any other jobs right now since you got rejected, or are you like just chilling, resting for now?
I think I'm chilling since I'm going to like the park every day, and I'm going to swim at like my community center. So just yeah.
Right. I see.
Ooh, you swim.
Yeah, I did track and I did tennis. I did
Oh
yeah.
wow.
And
That's
like
nice.
I play volleyball in my park because there's like a group there and like they're just there for the past 2 days and like wow, that's cool. And then now I'm gonna do swimming in like 10 a.m. where the water I don't care if the water is cold at all. Yeah.
Yeah, same.
Do you guys take cold showers?
Cold showers.
Nah.
Yeah, that's too cold. I can't do that. I can't
In
do
the
cold
summer,
showers.
Yeah,
yeah.
same. I cannot do
In
that.
Yeah.
winter, I can only take like a cold shower for like a minute and then I have to switch.
Yeah, too warm or hot.
Honestly, I feel like I only take cold showers when I feel like I have to take a shower fast because I just
Fast.
want to get out of there.
Yeah,
True.
but whenever you do, like you wake up like energizes you like afterwards, like all the adrenaline and stuff like that. It wakes you up.
Yeah.
Mhm. Dang.
I'm gonna do water polo next year, like men's water polo.
Oh, nice. Water polo.
I have no
That-
clue, but they just like made that a sport like this year. So
Dang. You're gonna be one of the original members, original team members.
yeah, but I'm gonna be in as a junior. So
Yeah.
Hmm.
I see. Muhammad, are you British? I kind of hear an accent from you. Like, what
Yeah,
accent is
yeah.
that
I'm not.
from?
I'm not. I wasn't born here. So
Oh,
I came here in like in 2022.
2022. Oh, in the UK?
Yeah.
Where were you born? Like originally? Like where you from?
I was born in the Emirates,
Emirates. Oh shoot.
the
Dang.
United Arab Emirates. That's
Oh,
where like
dang.
oh, you know it.
No, I don't know it. I'm just saying like I
Oh,
don't know. Yeah, I was like that.
it's like it's just where you know Dubai.
like Middle East.
Dubai?
Yeah,
Yeah,
that's the
yeah.
country where Dubai is.
Oh, I see.
Yeah.
Mhm. Dang. Yeah. So it was a nice talking to you guys. Probably see you guys tomorrow night if you guys can join. Yeah.
Yeah,
Well, I'll try.
Yeah.
Yeah.
my schedule's very
Yeah.
flexible.
Muhammad is like he's crazy. Like he's at like 6 a.m. at home right now.
Yeah, I put an alarm, but I almost slept through it.
Yeah, dang. What's your plan after? Like, or what are you gonna do after? Are you gonna go back to sleep or get out of bed, get ready for the
I'll
day?
probably go back to sleep.
Dang. Oh,
Yeah.
sleep well, sleep well.
Oh, thank you. Thank you very much. Is it night for you guys?
It's
Yeah,
10 o'clock.
10 p.m.
Yep.
Oh, wow.
Wait, what time is it for you?
It's 6 a.m.
6 a.m.
Yeah, he joined
Yeah.
at 5 a.m.
Dang.
Oh,
I know. Okay.
I don't
Yeah.
mind it though.
Yeah. It's good.
no, keep it up.
Early bird gets the worm.
Yeah.
Yeah.
Okay. I'll see you guys tomorrow. Bye.
Yeah. Bye
See you,
bye.
Okay,
Ryan.
then thank you. Bye bye.
Thank you.
No problem.
Bye.
Have a nice day.
Bye.
Thank you.
Have a nice
Bye.
day. Mhm. Jose,
What?
early bird gets the pushy.
Isn't it recording?
I mean the PC. The PC. Early bird gets the PC.
No.